everyone. Welcome to the video series of Exchange. As we have learned about the Stylus core concepts, basic introduction to Stylus. So now let's deep dive into the Stylus SDK that has been used to the both contract like ERC20.rs and lib.rs that has been used in the Stylus Foundation Challenge. So that you can get to learn more about the Stylus Rust SDK, which has been provided by Arbitrum Stylus. So as we have learned that Cargo Stylus is the CLI tool to manage the smart contract development in Rust. So let's look into the structure of the contract. So this is the main structure of the contract where we have two files, lib.rs and main.rs. These two are the main file for the smart contract development in Rust. The next comes the cargo.toml file where all the dependencies will be listed, like the version with the versions. And this is the important concept, like if you are familiar with programming languages, there we have variables like local variable, state variable and global variable. So local variables are only scope inside the function. For example, if you are declaring a function and if you have curly brackets inside it, so the scope of that variable will only relies inside that block till the function ends. You cannot access out that variable which has been declared inside the function from outside of the function. Okay, so the state variables are stored on the blockchain and it will cost you a more gas. And if you want to declare a state variable which are stored on the blockchain, then we can use the hashtag storage macros. So here hashtag storage, hashtag entry point marks as the starting point of the contract, and this struct will be stored onto the blockchain because this is the state variable as it has defined using @storage. Okay, so this is the Rust style. If you want to define Solidity style schema, then you can use sol underscore storage exclamation mark macros. This is the macro, this is the starting point, and if we are using the sol underscore storage exclamation mark, means it suggests that this is the state variable which needs to be stored on the blockchain. Contracts function are defined by providing an implementation block for the entry points contract struct, annotating that block with @public to make the functions part of the contract's public API. Means it's like access modifiers which you might have heard in the programming language like Java, where we have public, private, protected, and default kind of access modifier. And in Solidity, we have public, private, internal, and external modifiers. So it shows that these functions can be used by another contract or outside of the world's contract or not. If it marked as public, it means that that function will be used by any of the other contracts, and if it's marked as private, then it suggests that this can't be used by any other contract. So this is marked as public, so it can be called by any other contract. Okay, so modules, if you want to use one file to another file, it's kind of import export syntax. So if you want to use any single file into another file, then you can use modules. For an example, in our speedrun stylus foundation challenge, we have two files, right? In the SRC directory, we have three files, but only these two are the main files. So our logic will be defined in lib.rs, but that was using this erc20.rs. For example, here we are using mod erc20. It's kind of we are importing the erc20 Rust file into this lib.rs file. So that is the context of modules. Yeah, moving forward, events. So events are used to publicly log values to EVM, and that will occur while any transaction is happening. So you can define the events using sol exclamation mark macros, and then you can define it using event. Same goes with error. You can define it with sol exclamation mark macro. You can define the errors. We are deriving it using the Solidity error because as we have seen that Rust and Solidity are interoperable programming languages. So smart contract written in one language can be called smart contract written in another language. So here we are writing smart contract in Rust so that we are using the Solidity based syntaxes in our Rust smart contract because as we have seen that both are interoperable. So moving forward, So to print anything, you can use console exclamation mark macros. So this is same as print ln exclamation mark macro, which we have seen in Rust. So to print anything at contract level, you can use console exclamation mark macro. Comes from Stylus SDK provided by Arbitrum. So you have to take it like this. You have to extract it from stylus underscore SDK, and you can use console to print anything on your console. We have already seen that there are three types of variable: local, state, and global. Local variable don't store on blockchain, but state variable stored on blockchain, and global variable are already like a kind of public library which are already available, which you can use. Okay, so these are the global variables. As I have told you, if you want to know the timestamp, then you can use block.timestamp, message.sender. These are the global variables. If you use constants, then guess will be saved. Then you can define const using the constant using const keyword. Moving forward function, you can declare it using the fn keyword. Public functions, public function are marked as pub keyword. Internal functions, as you can see, internal functions are those that can only be called within the contract itself. It's kind of private functions. So if we want to declare this type of function, then we should not use address public macro. So this function is internal function, means another contract or outside entity cannot call this function of this contract. Okay. So moving forward, errors. So errors are two types: recoverable and unrecoverable. If the error is unrecoverable, we have to use the panic exclamation mark macro. Going forward, events. So for to get the event, we can use EVM colon colon log function provided by Stylus SDK. Let's see. For example, this is the sol exclamation mark macro. We are using the event, and we are using EVM colon colon log to log the event. Right? It will emit the event which is defined in this sol exclamation mark macro. Okay, so we have, let me explain you that thing here. So as you can see that inside our arc20.rs file, which has been used in Stylus Foundation challenge, that we are using EVM and message. These are the global variables which we are using from Stylus SDK. Then we are using, then we are declaring this trait. So trait is a kind of interface which we have in Java language, where we are only defining what to do, not how to do. So this is only the definition, and we are not defining how to do. Yeah, so mapping. Mapping is kind of hash map in the Java or C or C++ language, where we have key value pairs. So here also we have key value pairs. For example, if you want to track balance of different user, like how much token or different user have, then we can define this mapping, where we are storing the key as address and the amount of token that address hold. So that is like key value pair. So that is same as hash map in another programming languages. So we have declared events and solidity errors here also, which you may have a look. And then we are defining impl block, and we have marked every function as pub, so that can be used by other functions. And we have also make sure that these methods are marked as pub, so that are usable outside of the ERC20 module. They are callable from clip.rs, but these methods aren't exposed to other contract because we have not used uh, this @public macro. Because as we have learned that we need to use @public macro, so that this block impl block can be used by another contract, because this is full ERC20 standard. So that is marked as @public macro, so that can be used by other contract. This method can be used by other contract, but not this full implementation block, because it's not marked as public. And now comes to the ERC20 file. As we have seen that we are importing the module ERC20 file, then we are destructuring ERC20 and ERC20 params for it from it. Then we are this is a kind of implementing the interface. So here we have interface, which we have defined ERC20 params. So it's kind of interface in Java. So here we have this trait ERC20 params, and here we are implementing that in stylus token params we just have created using the struct keyword, so that this will be the definition of this will be given here. As I have told you that the trait is kind of interface where we only define what to do, how to do, and the definition of it will be defined by another file which is implementing it using for keyword. So this is the so definition of this trait will be defined in another file that will using this trait using for keyword. So here we have defined that things. Okay, so this is the entry point, and we are using the borrow macro. So to borrow means now we it will allow ERC20 access to stylus token storage, and we can make calls. For example, ERC we have declared here ERC20, so now it will borrow everything from ERC20 params, means this file. So we can able to call the public functions of this file inside this file, as we have used @borrow macro. So here we have used the @inherit macro to declare inheritance on the stylus token, which has borrowed properties of ERC20 token. Okay, so here we have done the inheritance. So here is the inheritance. We can do the inheritance using @inherit macro. So just like Java, Stylus doesn't support contract multiple inheritance yet. For example, we have marked it as ERC20. So this token will use the properties of ERC20. Okay, so if we are calling the balance of function on the token contract, then the function ERC20 dot balance of will be executed, because that function is there inside ERC20. Okay, additionally we are using the borrow trait, as you can see, borrow trait, so that this can borrow the value from ERC20 trait, which we have seen here. Okay, moving forward, we can get message as a global variable from Stylus SDK. Then we can get these values like message colon colon values. If you want to extract the data from the block, then we can extract block from the Stylus SDK, and then we can extract this much of information from block. If you want the contract information, then destructure contract from Stylus SDK, and then we can get this much information. Make sure that if you want to transfer it, then we can transfer that it to any another EOI address, means any another account, or we can transfer the it to any smart contract. If smart contract wants to receive funds, then we have to use @payable macro like this. That's why payable macro will be used to receive the funds. Okay, then comes to function selector. You can use function selector exclamation mark macro to select the function. So this is here we have to pass the function signature to select that function. Here we are selecting the transfer function which has been defined here, and we are passing that function signature here to select that function. So now we have covered basic of Arbitrum Stylus, Arbitrum Nitro 11 node, Stylus SDK, and Rust smart contract. So now you can come to the modules.xcan.dev site, comes to the second module, Stylus core concept. As we have already explained about Rust, WASM fundamentals, mapping arrays, given you real world examples for this Stylus Foundation challenge, constructor storage, event, and error handling. Everything has been explained in depth, so that you can start to learn more about this chapter, where we also have 6 chapters inside this module. So everything has been covered. So yeah, if you have any doubt, please feel free to reach out to us. Thank you everyone.